This is homework help for lesson 5.1. We'll be working on numbers 8, 10, 12, and 18. Let's go back to the beginning of lesson 5.1, and the first definition that we had was the definition of the perpendicular bisector. Okay. So, what does a perpendicular bisector do? A perpendicular bisector is a line that divides a side of a triangle into two equal pieces and will also travel across to the other side of the triangle. So take a look at this picture from your book, and I'll start here with the side of this triangle. It's an acute triangle, and we measure halfway. So the first thing you do is measure halfway across the segment, okay? Put a little mark there, and then get your protractor out and line up the protractor so you can see the 90-degree mark. With your protractor on this segment, even if you have to go outside of the triangle, mark where 90 degrees is. Mark the point where 90 degrees is on the protractor, and then draw a line from the middle of this side to the 90-degree mark. You'll have a line that goes across like this, and it will have divided both of these, and it will be 90 degrees. Okay? Now go to another side and do the same thing. Put your measure halfway on the segment, make a mark, put your protractor on this segment, and you might want to turn your drawing around to do this. Measure out to 90 degrees and then draw a line. So draw a line through. Now you will have two lines that have an intersection at a point on the triangle. Right on this triangle, it's labeled as point C. For preciseness, or for correctness I should say, you want to do the third side also, because it's very easy to draw these lines inaccurately. So on the third side, measure halfway, put your protractor on the third side, and measure up to 90 degrees and draw a line. All three of those lines should meet at one point. That will be where the three perpendicular bisectors meet, and the three perpendicular bisectors meet at the circumcenter. Okay? So perpendicular bisectors and circumcenter. Okay? Now, if you look at number 8 in your book, it says copy each triangle. Draw the perpendicular bisector of each side. So here's the triangle for number 8. You have 3 different ways you can copy. You can put your paper on top of it and just copy it through your paper. Or you can draw the triangle similar. You can measure these angles and draw a triangle larger but similar with the same angle measure. Or you can use your compass to actually draw this triangle and copy it the way we've learned in previous constructions. Either way is up to you. So this is the triangle, and the first thing you do is draw this triangle while this video is paused. And once you've drawn the triangle, come back, measure all three sides, and find out where the middle is and mark them. So I have marks right here, and I'll go ahead and X those marks so you can see the middle of my sides. From there, you will draw perpendicular bisectors. So I'm going to start with, I'll just label it just to be able to identify it better for you. Here is side AB. I'm going to draw a perpendicular bisector. I put my compass right here on this line. So you line up your compass, find 90 degrees on my compass, it'll be about here, and then draw a line. So I have my first perpendicular bisector drawn, and it actually will divide this side into two equal spots. Now I'll go over to this side here, AC. Sorry. And I will draw another perpendicular bisector. I will put my protractor on AC, and I will look for 90 degrees, say 90 degrees is about here, and I will go ahead and draw a line from my midpoint to my 90 degree mark, and that will once again divide this side now into bisected segments that are equal, and then we will do the third side. So you can see my midpoint mark right here. I will put my protractor on this line, CB. I will find 90 degrees, and then I will draw a line, and because I'm not actually using a protractor, I'm going to guesstimate this for you, okay, to fit right there. Now we'll have our third side done, and these are equal parts also. What does the question ask us? It said copy each triangle, draw the perpendicular bisectors, then make a conjecture. The conjecture is, where is the concurrent point for these three lines? Well, it is in the inside of the triangle. Okay, now we'll move on to number 10. Now number 10, number 10 is an obtuse triangle. It means it has one large obtuse angle. And what they're trying to get you to discover here is where points will be concurrent for each one of these different triangles. So what we'll be doing in this one, we will find the midpoints of each side. So you measure with your, sorry, that should be green. You measure with your protractor or your ruler to find out where the midpoints of the sides are. And then you are going to draw perpendicular bisectors. So this bottom base, which we'll name AB, will be the first one we start with. And AB, we will draw a perpendicular bisector by measuring once again from AB to 90 degrees on your protractor, marking it, and then drawing a line. So we have our first perpendicular bisector. Now I'm going to use the side CA, and I will do the same thing. And I just realized something. My perpendicular bisector here is not going to be long enough. So let me fix that. From CA, we will draw another perpendicular bisector. And each one of these you want to draw out beyond the triangle. This is how it's going to work, and this is what I encourage you to do on all the triangles. Don't try to stay inside like the pictures in the book. Don't try to be super neat with these. Just draw the lines the way that they're supposed to be. The last line, BC, once again, measure that from your sorry, had to stop there for a moment. Mine is not going to line up correctly, so what I'm going to do is give you a visual of what it should look like. Once again, from CB, you measure 1/2 of that line. You line up your protractor. I encourage you to turn the paper around so CB is on the bottom of the triangle. It'll make it easier. Measure to 90 degrees and then draw a line, and the line should meet the other two lines, and it will be where? It will be outside the triangle. So perpendicular bisectors, what do? They divide or bisect the triangle sides. So you'll have these equal pieces. They also will be 90 degrees at each side. Number 12 says copy each triangle and draw the altitude from each vertex. Then make a conjecture. So we need to review the altitudes that we were shown in the book, and there are different places that altitudes will drop depending on the type of triangle. So if you have a triangle, and this just is a standard acute triangle, what an altitude is a line that is dropped from the vertex to the opposite side, and at the opposite side it meets at 90 degrees. So an altitude is vertex to opposite side. It does not break the sides into two equal pieces. It doesn't bisect the angle. It's just a line dropped from a vertex to the opposite side. In a right triangle, what happens is, here's a vertex, and if you drop at a 90-degree angle to the other side, that's actually a side of the triangle. So with the right triangle, which is what we have down here, this is what happens. So if I start here at A and I drop a line from the vertex to the opposite side, it's actually the side of the triangle. And your answer would be that because it asks you make a conjecture related to the location of the orthocenter. That would be where all three lines meet. So we've drawn AC, and that line goes straight here. Here's B. The vertex of B dropped to the other side would be also the side of the triangle. And for AB, the vertex to the other side I'll have to draw it from the other direction. The vertex to the other side would look like this. Where do A, B, and BC and AC meet? Well, they meet right here at the point C. That's your concurrency. So where does the orthocenter, where is the orthocenter for this triangle? Well, it's at the vertex of the right angle. So it's at the vertex of the right angle in this triangle. Okay. Sometimes with these triangles where we're drawing altitudes, the vertex, the orthocenter could be inside or outside also. But for the right triangle, it'll always be at the vertex. And I mean always, so that's something you can count on, and it's something that you could have in your notes to be sure of. We'll move on to number 18. Number 18 is part of a series of triangles, and it says to use triangle ABC and triangle PQR for the exercises. 18 refers to ABC, and how do I know that? Well, number 18 says name all the illustrated perpendicular bisectors. By looking at the other triangle, which we'll do more in class, I can tell the difference between which is the perpendicular bisector and which is not. How do I know these are perpendicular bisectors? The lines are halfway on the side, they meet at 90-degree angles, and they divide the side into two. So we know that these are perpendicular bisectors. Okay? Now it asks us to name all of them. Are we naming anything that has a dotted line? No. What those dotted lines are part of the example where we drew the circle around the triangle, and we showed that these are radii of that circle and that they're all equal. So we're only using the solid lines. These are our perpendicular bisectors. They look a little different than the triangle you drew because they erased the lines all the way through. So they stopped right here at the circumcenter. So D is the circumcenter, and this is not what they're asking you, but this is something you need to be able to understand. And knowing that that's the circumcenter, you're going to have segments that start with D because they're going to be part of that point, and there will be 3 of them because you have 3 sides. So all we need to do is identify the other side, and the first one that I see is DZ. So it's the line that meets at the side of the triangle that is 90 degrees. We also have DY, and then we have DX. And that's it. Those are the illustrated perpendicular bisectors. And if you want to see those a little more clearly, there they are in your triangle.